Okay, I think I'll just start while Victor is setting up anyway. That is my whole job, is to buy him a bit of time today. So let me introduce us. So today we're going to show a little demo of fruit detection, and Victor will tell you a bit more about the ins and outs of this demo. With me is Victor and myself, and just very briefly, we are both from Axelera, and just to tie in what we are doing today and showing you today, and what we are doing as a company, we are actually producing or selling chips, systems, M.2 and PCI Express form factors, as well as the single board computer spaces, and bigger boxes with more performance. And together with the software solution, the Voyager SDK as we call it, we offer kind of a complete vertical solution for edge AI applications. And you can see like those two typical applications here. One would be kind of the self-checkout kiosk, where in the kiosk there is this PCI Express accelerator, and it detects all the objects that are being put into the bag. And the other one would be a typical pick-and-place machine that is running this pick-and-place automatically. And why are we here at the RISC-V Summit? Because some of the core technology within the chip is RISC-V. And just to kind of tie it into the summit, the really, really core technology is our digital in-memory compute array, which is doing a matrix vector multiplication. Then we have some auxiliary engine that is doing all the other applications, all the other operations of a neural network like pooling and depth-wise convolutions, as well as a small vector engine that's not RISC-V, but that it's doing the element-wise operation. And that is being then tied together by a scratchpad memory, data movement engines, and a RISC-V core that is controlling all these units and orchestrating the data flow within these components. And then in the Metis chip that Victor is showing in a minute, we have 4 of these, what we call AI cores. And for the first generation, we are using off-the-shelf Andes IP. You can also visit the Andes booth there. It's the same picture. And for I'm doing a bit of advertisement. There is going to be a note from myself later, I think 3:15, where we will be announcing the next generation, where we have some exciting things around RISC-V that I will show. And then these 4 AI cores, again, are then tied together by another RISC-V core that is doing the whole SoC management and the root of trust for security. That's basically it from my end, and I'll hand off to Victor for the fruit demo.
Okay, so yeah, I'm Victor Labian, so customer engineer at Axelera, and I'm going to demo this for you. So basically here we've got an Orange Pi, very cheap host, as you know, and the Orange Pi has an M.2 slot, so it's perfect for putting our Metis M.2 card in there. This is great because basically the Orange Pi has 4 lanes PCI Express 3.0, which is what we use. And also it has an integrated GPU that we can make use of with OpenCL for doing pre and post processing. So it's really great to show how we can use Metis in a host like this one, right? Really cheap and embedded host. Now I'm gonna try to run this demo here. So let's see if we are lucky and everything works. So this demo basically, it shows how versatile is our SDK. So as Florian explained, we've got 4 AIPU cores. And we are showing how we can use these AIPU cores to run different models, cascaded, in parallel. So basically here, what we show is like we want to do some segmentation and fruit detection, which hopefully is now working, yeah. What happens is like we use YOLO V8, but if you go far away with YOLO V8, you downscale to 640p. And that's an issue because if the object is too small, if you are far away, it won't get detected. So what we do is running a YOLO V8L pose to detect the people in the screen. And then we take that part in high resolution, then downscale, only that part to 640. So that way we are actually having a much better resolution to actually detect the fruits. So we are doing this in parallel, running the object detection on one side, doing the pose plus segmentation on the other side, and we can also choose how many AIPU cores we use. So we use 2 cores for the segmentation, we use 1 core for the object detection, we use one core for the pose detection. So now let's see. I'm gonna come here and let's see how this works. So as you can see, it's detecting this banana. So basically, you see the pose estimation. You see like how it's detecting my body, and that's cropping myself from the screen, and that and then it is down scaling to 640, but only to myself. So that is the reason we can detect this when doing the segmentation. It's taking the region of interest and input as input rather than the whole downscaled screen. And that's more or less how this works. So if anyone want to test, and yeah, that should be it from my side.
That's a persimmon.
But you can go a bit far away, maybe it will detect it. Not really. Nah, it's with the screen. You can try with this.
I seem to have messed up the focus.
Yeah, I think you went too.
There we go.
And you can move farther away, yeah.
We have a couple of more demos in the booth as well. That's right there at the entrance. So if you're interested in some other demos and partner demos as well of applications, I'll feel free to check it out.
Thank you.
Thanks.